Assalamu alaikum students. So our today's topic is the law of sines. We have practiced using trigonometric ratios to find side lengths and angle measurements in right triangles. All of these SOHCAHTOA will help us in right triangles only, and they are really useful in a real world situation. But what if the triangle is not right and it's an oblique like this, not a right triangle? Then surely we can do something to find out the sides or the angles of that oblique triangle. Okay, so there is, wow, and one of them is called the law of sines. Law of sines says that if there is an oblique triangle with angles A, B, and C, all these angles capitalized, and sides A, B, and C, all these sides with lower cases, in such a way that side A is opposite to angle A, side B is opposite to angle B, and side C is opposite to angle C. Okay, so what sine law says that the relationship between the angles and the opposite side is proportional. It can be used to find the side length and angle measurements for any triangle other than any triangle. Okay, and it says that sine of angle A, the ratio of sine of angle A to the side A which is opposite to angle A, this ratio is proportional to sine of angle B to side B, and it is also proportional to sine of angle C to side C. Okay, now it could also be written in the form of, because they are ratios, we can flip them off, and I can write it as A over sine A is equal to side B over sine angle B is equal to side C over sine angle C, because they are ratios. Okay, we can use any of these forms, but make sure if the sides are in the numerator, then angles are in the denominator. If the angles are in the numerator, then sides are in the denominator. Okay, now we are not going to use actually all these three at once. We will be using any two ratios to find the side, because use the law of sine to set up a proportion and solve for x. Because here I know if this is A, B, we don't have to actually name A, B, C. We know that if this is the angle, the side opposite to this would be this one. This is the angle, the side opposite to this would be that. So I can set up a proportion saying sine of 71 degrees over the side opposite to this is x is equal to the ratio of sine of 35 degrees over to the side opposite to this is 12. Now from this point we just have to find the value of x. What we can do is, because x in the denominator, I'm going to multiply both sides by x so that I can get rid of the x in the denominator. Okay, so I'm going to multiply x on both sides, cancel of this x, I get sine of 71 degrees is equal to sine of 35 degrees times x over 12. Now I'm going to multiply both sides by 12 so that I can get rid of 12. I get this. Now I'm going to divide both sides by sine of 35 because I want to get rid of sine of 35. Sine of 35 equals to x. So what I'm getting is 12 sine of 71 over sine of 35 degrees. Make sure your calculator is in the degree mode, equals to x. I'm going to use my calculator. 12, let me clear everything up. 12 times sine of 71 degrees divided by sine of 35. My final answer is 19.78. It's in degrees, so I'm going to just round it up to the nearest tenth. I get x equals 19.8 degrees. the same process we are going to do here. Okay, so here we have to find the side. It's an oblique triangle. We will be using law of sines. Law of sine is used when we have at least two angles, or one of the side, or two sides and one of the angle. We use this law when we have angle, side known, or we have angle, side, angle. Okay, then we can use sine law. Okay, now here I have two angles, one of the side. I have to find the other side. I know that 73 is opposite to this, 59 degrees opposite to this. Now one easy way is, if we have to find the sides, I know that at this point, if I use this ratio, my x will be in the denominator, and it takes so many steps to get rid of it. It's easier if we just keep sides in the numerator. When we are looking for sides, we keep sides in the numerator, and when we will be looking for angles, we will be keeping angles in the numerator. Because they are ratios, it really doesn't matter. That's what I just showed you this way. I'm gonna use this way. That would be really easy, because I'm looking for sides. It's better to have sides in the numerator. Okay, so now I'm gonna do x over sine of angle 59 degrees should be equal to 20 over sine of 73 degrees. Now at this point, we just have to get rid of sine of 59. I'm going to multiply both sides by sine of 59 degrees, sine of 59 degrees, so that I can cancel this off and I get x equals to that. When I plug this into my calculator, I get 20 times sine of 59 divided by, oops, look, I have to close parentheses, otherwise my value will be wrong, divided by sine of 73, parentheses closed. Okay, if you do not close the parentheses here, then you'll get a wrong answer. So I get 17.92, rounded off to the nearest tenth, I get x equals 17.9. Yeah, oops, this is not degrees because it's a side. Okay, so x equals 17.9. Final answer should be nearest tenth. Okay, now in this case, we know that if we know two angles, we can find the third angle also. Okay, at this point, I know I have this side, but I do not have the opposite angle here. I know sum of all the angles equals to 180. So actually, this angle would be, I add them and subtract from 180, I get 48 degrees. Okay, so now because we are looking for sides, the hint is, when we are looking for sides, keep sides in the numerator. Okay, so I'm going to take x over sine of 48, the opposite angle, is equal to 15 over opposite angle is sine of 29. Okay, for any oblique triangle. So now I'm going to multiply both sides by sine of 48 degrees times sine of 48 degrees. I'm going to plug it into my calculator. This cancels. I get x equals to 23, which is the side length. Okay. In this case, the same. I know this side, but I do not know the angle. I can always find the third angle because of these two angles. This will be 89 degrees. Now I can use this over sine of that and this over sine of that. I don't have to actually use this angle because they just want to find this x. Okay. Now let's move on to when we have to find angles. Okay. When we have to find angles, I said we will be using sine A over A equals sine B over B equals sine of angle C over side C. Okay, So that's easier for us to work with angles when they're in the numerator, and when we're working with sides, it's easier for us to use this. Although you can use both in both the cases, they will end up with the same answers, but your work will be less in this case. Okay, finding the angle measures. Okay, now here I have this angle and the side, I have this unknown angle and the side. So I know I'm gonna take either I start from this angle, I start from that angle, it really doesn't matter. So I'm gonna write sine of angle x over 9 is equal to sine of 77 degrees over 14. Okay, now I'm gonna multiply both sides by 9 so that I can get rid of 9. I get sine of x equals 9 times sine of 77 degrees over 14. At this point, we know when we are looking for an angle, we have to take the inverse. Remember, we have to take the inverse. So what am I going to do is I'm going to first calculate this sine of x equals. At this point, I'm going to do 9 times sine of 77 degrees parentheses divided by 14. I get this answer. Now when I'm taking the sine inverse, I have to take the exact value, or at least take 4 decimal places when you're copying it. 4 decimal places. So sine of x is equals to 0.6264. This will be rounded off to 4. Okay, so 0.6264. Now because we have to find an angle, always remember when we are looking for an angle, we do sine inverse, second function, sine inverse of 0.6264 close parentheses, I get 38.78 degrees. So I'm going to degrees we take into 1 decimal place, 38.8 degrees. Okay, 2 things to remember. At this point, when you're finding an angle, keep sine angles on top, and when you find this value, make sure you take 4 decimal places, so to be at the safe side and you get the exact value, then you take sine inverse of 4 decimal places numbers. Okay, and the final answer should be in 1 decimal place. Okay, so that we are on the safe side. Now let's do one more question for this. I need to find an angle. I have its opposite side. I have an angle and its opposite side, so I can set up a ratio, proportion. So I'm going to write sine of x over 21 equal to sine of 61 degree over 24. I'm going to multiply both sides by 21. I get sine of x equals 21 times sine of 61 degrees over 24. I'm going to plug this into my calculator. Okay, 21 times sine of 61 close parentheses divided by 24. I get 0.7. This decimal I have to take 4 places, 1, 2, 3, 4. So it will be 0.7653 because after 2 it's 9. So I'm going to write sine of x is equal to 0.7652. Oh, sorry, 4 decimal places. Now I'm going to take the inverse. X equals to sine inverse. This is sine inverse of 0.7653. Plug it into your calculator. Second function, sine inverse of 0.7653 parentheses close. I get an angle 49.9 degrees. So x is equal to 49.9 degrees. Okay, now I hope you understand the concept. Just remember the hint. When we are looking for angles, keep sine of angles in the numerator. When you're looking for sides, keep sides in the numerator and the angles in the denominator. And at this point, when you're finding an angle from the inverse, please use 4 decimal places to get the exact value at least. I hope you understand the question. Assalamu alaikum.